This video is a continuation of our discussion of equations of motion when acceleration is constant or uniform. In this particular video, I'll be talking about motion under gravity. Now, when you say motion under gravity, you are talking about when an object is dropped or when an object is thrown upward. In whatever case, you can apply the equations of motion whenever an object is dropped or whenever an object is thrown upward. If you throw an object upward, let's say a ball, at the maximum height where it comes to a temporary stop, the final velocity is 0. Then if an object is dropped, the object does not have an initial velocity, because when you release an object from a height and the object is falling to the ground, it only has v, it doesn't have u. So when an object is falling, u is 0. When an object is thrown upward, v is equal to 0 at the maximum height. These two things have to be put into consideration whenever you are talking about motion under gravity. Then another thing you also need to know is that when an object is thrown upward, the acceleration a in the equations of motion becomes g, and that acceleration becomes minus g, meaning the acceleration due to gravity is negative when an object is thrown upward. Then the same thing or something similar can be said about when an object is dropping. The acceleration is equals to g and it is positive, meaning it will be plus g. So for the equations of motion under gravity, you replace the a with g. It's going to be plus g when an object is falling back to the ground, and it's going to be minus g when an object is thrown upward. So if you rewrite the equations of motion, you are going to have v equals u plus gt, h equals ut plus half gt squared, v square equals u square plus 2gh. You use these equations anytime an object falls freely under gravity. When an object is thrown upward, these equations become v equals u minus gt, h equals ut minus half gt square, v square equals u square minus 2gh. In these equations, v is the final velocity, u is the initial velocity, t is the time, and h represents the vertical distance. G is the acceleration due to gravity, and it is approximately 9.8 meters per second square, or sometimes 10 meters per second square. Let's now take an example on how to use these equations of motion under gravity. Example: the observation deck of a tall skyscraper is 370 meters above the street. Determine the time required for a penny to free fall from the deck to the street below. Let's solve this example. From the question, the observation deck of the skyscraper is 370 meters above the street. So we are given the height or the vertical distance to be 370 meters. Then you are asked, or we are asked, to calculate the time it takes for a penny to free fall from the deck to the street below. So we are looking for the time. So how do we get the time? Remember your equations of motion. You need to take the one out of the three of them. You take the one that has to do with what you are looking for and what you know. So I'm going to take or use the equation that has to do with h is equals to ut plus half gt squared. Now plus because in the question we are being asked to calculate the time it takes to go down the street below. Okay, so the motion it has to do with an object falling downward. Okay, so that's why this is plus. Now from the question we know that h is 370 meters, so I'm just going to write that. Then for objects that are dropped or objects falling freely, u is 0, so I'm just going to do 0 multiplied by t because the object is falling freely, then plus 1 over 2 multiplied by the acceleration due to gravity. If we take it as 9.8, I'll write 9.8, then meter per second square, of course, then multiply by t squared. I'm looking for the time. So if you continue with this, you are going to be getting 370 meters is equals to 4.9 meter per second squared. Let me put this in brackets, multiply by t squared. So I'm just going to put this onto in brackets so that you don't mix it up with the t squared. Then if you use your calculator to do this, you are going to get your time is equals to 8.69 seconds. Okay, if you use your calculator. Alright, how did we get 8.69 seconds? First, you divide both sides by 4.9, then after that, you look for the square root. This time, 8.69 seconds, is the time it will take for a penny to free fall from the deck to the street below. I hope you understand. Let me take another example. Here is our second example. A coin was thrown vertically upwards and it rose to a length of 10 meters. What is the velocity with which the body was thrown upwards? Let's solve this. For this example, the vertical height or the vertical distance is 10 meters because from the question, we are told that the coin rose to a length of 10 meters. Okay, and we are looking for the velocity. Now, this example has to do with an object thrown upward. So the equation of motion we are going to use is the one that has minus. Okay, so we are going to pick the equation that has to do with what we know and what we are looking for. I'm going to use the equation v square is equals to u square minus, I hope you know why it's minus, because the object is thrown upward, then 2gh. Then anytime objects are thrown upward, I told you that the v will be 0, so that's why this is 0. Then you have u square. Now this u is what we are looking for, and it is the velocity with which the body was thrown upwards, then minus 2 into bracket acceleration due to gravity. I'm going to use 9.8 for it per second squared, then multiplied by the height h. Okay, so since we are given the height, I'm just going to include the height so that we don't waste time. So I'll just put 10 meters. Then 0 will be equals to u square minus, if you do this with your calculator, you are going to be getting 196 meter per second all squared. Okay, then this means u square will be equals to 196 if you do the mathematics. Okay, if you add 196 to both sides, meter per second all squared. Then if you find the square root of both sides, your velocity, that is the velocity with which the body was thrown upwards, will be 14 meter per second. I hope you understand. If you don't understand, you can send your questions to me and I will gladly answer them. Thank you for listening.